Okay, so this is the last lesson now, okay, on trig equations. We're going to use something called the fundamental trigonometric identity. This sounds complicated. It's not too bad, but the algebra gets quite sticky, okay? So this fundamental identity, fundamental means like, you know, very, very important. And this one is, okay? The key fact is, all right, for any x you want to pick, any angle you want, okay? If you do sine of the angle and square it, plus cos of the angle and square it, you always get 1. Remember, this here means identical to 1, okay? That means that it's the same for any x you pick, any x you want, 30, 40, 275, all right? 0.1, you will get the answer 1, all right? But this notation here is quite clunky. So from now on, okay, I'm going to use sine squared x to mean the same as sine x, and cos squared x to mean the same as cos x. This notation is less clunky, okay? It looks better as well. So this here, okay, is unbelievably important. We need it all lesson today, okay? So we can use this identity to solve quadratic trig equations, like example 1, which I put here, okay, on its own slide. This is example 1. All right, we've been asked to solve in this range, all right, basic range, this equation here, okay? I'm going to call this equation 1. And what you can see, all right, is that I've got a cos and a sine, which is bad. Even worse though, okay, I've got cos squared and the sine. That's not going to do, okay? But I know, all right, that, and I always write this down, sine squared theta plus cos squared theta, all right, equals 1. I know that on the previous slide I used x, all right, but x, theta, Jeff, Barry, Z, it's all the same, okay? All right, and then my goal, see, all right, if you look at this formula here, all right, this sine theta is not quadratic, all right? This formula only deals with quadratics, so I can't do anything with this sine theta, but I can see cos squared theta in this, all right? So what I'm going to do, I'm going to rearrange this formula, all right, to get cos squared theta on its own. This is a positive sine squared here, okay? So I would take it off. And cos squared theta, okay, is the same now as 1 minus sine squared theta. That's basic from GCSE. All right? And I'm going to put that into equation 1. Wherever I see cos squared, I'm going to put this definition in, okay? Remember, this means 6 times cos squared theta. So I'm going to get 6 times 1 minus sine squared theta, okay, plus sine theta equals 4. And this is good because now I've got all sines, all right? Expand the brackets. You're going to get this, okay? And again now, all right, this is going to be quadratic. And if I got quadratics, I always want my squared term to be positive, okay? So I'm going to do this now, okay, in one line. See if you can cope with what I'm going to do. I'm going to take this sine 6 sine squared over there, all right, to make it positive, all right? And so this sine will go over here as well. That'll become minus. And then this 6 is positive. So over this side, I'll take it away, okay? 4 take away 6. Sorry, that shouldn't be there. 4 take away 6. Okay, is minus 2. And obviously the left-hand side will be equal to 0 because everything's gone. And I just turned the whole thing around. Okay, this looks scary, but from GCSE, if the signs were just x's, see, we could factorize this no problem. Okay, so I'm going to factorize it. Okay, 3 sine theta minus 2 is one bracket, okay, and then 2 sine theta plus 1 is the other bracket, okay? If you don't believe me, expand this out and you will get this left-hand side, Obviously, if you can't factorize things like this, you need to go back on the Maths Watch or look through your GCSE books, okay, and recall how to factorize these things when the x squared coefficient is not equal to 1. Okay, remember now, either the first bracket equals 0 or the second bracket equals 0 plus 1, sorry. And so, again, I hope you agree here that this one, I'd have to add the 2 on and divide by 3. And this one, I would take the 1 off, all right, and divide by 2. And then we've been solving these equations now, okay, for the last 3 lessons. So I'm not going to show you the workings out. This first option, you're going to get 41.8 degrees and 138.2 degrees. And on this one, you're going to get 210 degrees and 330 degrees. That's a lot to take in on that example, all right? But I'd watch it again, okay, and make sure you understand all the steps. And in the next video, I'll do example 2 with you, okay? So I'll see you shortly. Okay, welcome back. So for example 2 now, all right, we're gonna do this one. Again, I put it on the next slide on it by itself, all right? So again, simple range. I got a mixture of cos squares and sine squares and causes. Okay, so I'm gonna have to use my fundamental identity, okay? So always write it down. Sine squared theta plus cos squared theta equals 1, okay? And this one, okay, we'll have a look, all right? If you scan to this, you can see that this cos theta is going to be a problem, and there's nothing I can do with it, all right, because this identity only mentions cos squared. So that means that this 2 cos theta here, okay, has got to stay because there's nothing I can do with it, all right? And that means that all the cos terms have got to stay. So I'm going to have to get rid, okay, of the sine squared here, okay, because I can see sine squared here, all right? This cos is going to wreck the cos side of things. So for this one now, I'm going to have to get sine squared on its own. But again, you can just take off the cos theta because it's positive on the other side. You can just take it away, all right? And you can put that into equation 1. So wherever you see sine squared theta now, you're going to put in 1 minus cos squared theta, okay? So the first term is going to stay as it is. And so is the second term. This is going to be 3 times 1 minus cos squared theta minus 2 cos theta, okay? So I'll expand the brackets on the right-hand side first of all. Okay, and you're going to get 3 minus 3 cos squared theta, sorry, minus 2 cos theta. All right, and the goal then, okay, is with these quadratic terms, all right, to get the positive squared term, okay, and have the right-hand side equal to 0. Well, luckily for me, okay, I can see that this is negative here, this one, and that's positive. So I will take this minus 3 cos squared theta over the other side. So I will add it on. And 5 cos squared theta plus 3 cos squared theta, okay, is 8 cos squared theta. Okay, I'm also going to take this term over. So it's going to become positive 2 cos theta. All right, so that's done and that's done. The only thing left is this 3. Now this is positive 3. So I'll take it off, okay? And 2 take away 3 is negative 1. And again, okay, if this scares you, just think about 8x squared plus 2x minus 1 equals 0. Okay, it will factorize. All right, I've done it. It factorizes to 4 cos theta minus 1 times 2 cos theta plus 1 equals 0. Okay, again now, either the first bracket is equal to 0, all right, or the second bracket is equal to 0. All right, this one, look, okay, I'll add the 1 on, then divide by 4. So cos theta it's going to be positive 1/4, or this one, take the 1 off and divide by 2. All right, and then again, this one, solve as before, take the inverse cos, yada yada. Okay, you get theta equals 75.52 degrees, or 284.48. I've got the 2dp for this one. Okay, I fancy the change. 102dp is completely fine. And this one here, okay, you get theta is 120 again, or 240 degrees again. Okay, and that's that one solved. Okay, so on the next slide now, we got the main task. Okay, we'll get rid of that in a minute. So pause it, have a go. This will take you half an hour probably. There's a lot of work to be done here, and I'll show you the answers shortly. Okay. All right then, welcome back. There's the answers there. All right, so make sure you mark what you've done. All right, and then here comes the checking question. All right, so again, I'll put it nice and big. So pause it and have a go. All right, and then we'll go through it together like we always do. All right. So again, usual thing, the range is fine. All right, I know that sine squared theta plus cos squared theta equals 1. That's equation 1, sorry. You look at this one, you can see, look, right, this cos is going to have to stay because there's no mention of cos, and this is only cos squared. All right, that means that the sine squareds have got to go. All right, so you've seen this before now. Sine squared theta equals 1 minus cos squared theta. Okay, put it into equation 1, and you're going to get, well, 10 cos squared theta plus 3 cos theta equals 4 brackets 1 minus cos squared theta minus 2. All right, so as always now, one thing at a time, we'll expand the brackets first. Okay. You get 4 minus 4 cos squared theta minus 2. And again, look, all right, we want to have a positive cos squared. So I'll take this negative 4 cos squared over here. That'll be 14 cos squared theta. Okay, and that's gone. There's no cos's over here, so it's going to be 3 cos theta here. And can you see, look, on this right-hand side, 4 take away 2 is actually positive 2. So if I take it over here, it's going to be negative 2, okay? And that equals 0. This one's okay to factorize because 14 really is only 2 and 7 really, isn't it, okay? So I factorized this. Took me 2 goes, but I got it. 2 cos theta plus 1 times 7 cos theta minus 2, okay? And that equals 0, okay? And that means that for this one bracket, all right, either the first bracket is equal to 0, okay, or the second bracket is equal to 0. Sorry, I got a bit disturbed there. Sorry. This one here, cos theta will be equal to negative 1/2, or cos theta equals 2/7. So 2 there, sorry. And again, solve these in the usual way. All right, you're going to get theta equals 120 degrees or 240 degrees. All right, and this one you're going to get, I went to 1 dp here, I got 73.4 degrees or 286.6 degrees, okay? And we are done. These equations won't get any harder than that, so if you cope with that, well done. If not, watch it again and practice, practice, practice. Nice one.